Lesson 7.8, Simple Probability. An outcome is the possible results of an experiment. An event is a collection of those outcomes. Favorable outcome is when you specify an event, it's the outcome of that event. That's your favorable outcome. Probability of an event is the likelihood that an event will occur. We will discuss more of these words in context with the problems. There's two types of probabilities we're going to be learning. Theoretical probability and experimental. Theoretical probabilities, and start where it says, when all outcomes are equally likely, this is, and actually you can start here. It is the ratio of the favorable outcomes to the number of possible outcomes. So it's favorable outcomes to the number of possible outcomes. Experimental is the result of a sample or experiment, and it is the ratio of the number of favorable outcomes to the total number of times the experiment was performed. So it's your favorable over your trials, how many times the experiment occurred. Theoretical probability of an event is really when you're asking the question, what if? What if I did this? What if I flipped a coin? What if I rolled a dice? It is the number of favorable outcomes over the number of possible. What if I flip a coin and I get tails? Okay, tails will be my favorable outcome. The total possible outcomes would be the choices. So for example, in that scenario, it would be tails over the choice of two, tails or heads. So your probability of getting a tails is 1 out of 2 choices. Let's talk about using theoretical probability. We're going to predict, okay, and we're saying predict because we're going to say, what if I roll a number cube? And that number cube will land on an even number in 20 total rolls. That's your possible rolls. You have 6 equally likely outcomes on the number cube. Okay, and a number cube is a die, okay, so it has 6 sides, 1, 2, 3, 4, 5, 6. Let's talk about how many are even. The even numbers are 2, 4, and 6. So there are 3 out of the possible. Which is 6. So you can predict that 1/2 or 10, now where did I get 10? Well, 1/2 of the 20 rolls, okay, there's that word, of the 20 rolls. So take 1/2 times 20, and you'll say that 10 rolls will have an even number. That's what you predict. Is it actually going to happen? Probably not. But we are saying, what if I rolled a number cube? What are the chances that it is an even number? Experimental probability is a little bit different because you are actually going to do the experiment. You are actually experimenting. Actually, let's even call it actually trying. You spin a spinner 150 times. Your results are shown. So a lot of times when you do experiments, you make a table of some sort to show your results. What's the probability of spinning a yellow? Now, by the way, they put this P with the parentheses over it. This is the probability, and then inside the parentheses is what you want, your favorable outcome. Spinning a yellow. Well, there was 18 yellows when I did my trial. What was the total number of spins? 150. Again, if you remember from the beginning when I talked to you about the vocab, I've said it was experimental is favorable over the number of trials. This simplifies to 3/25. Okay? And now you can change that fraction into a decimal, which you can become a percent. So you can actually say 12% of the rolls, or 3 out of 25, is going to be a yellow. The spin, excuse me, is going to be a yellow. Example 3. You randomly draw a tile from a bag of A, B, C, and D letters 16 times. Are you actually doing this? Let's talk about this quick. Is it theoretical or is it experimental? Remember, this is asking the question, what if? Experimental is actually trying the problem. You randomly draw a tile from a bag 16 times. You're actually doing it. I'm actually going to put actually trying. That means this is going to be experimental. Each time you record its letter and place it back in the bag. There are 75 letter tiles in the bag. About how many tiles in the bag would you expect? Again, we're expecting it to be the letter C. So, the probability of letter C, take how many times you got letter C. So this is 5, 6. How many times did you draw a letter? 16. Simplify 3 out of 8. So if I pull 8 times, I'm going to get a letter C, 3. We now need to multiply the probability, and this is what I said before. So 3 out of 8 times was a letter C. 3/8 of the 75 letters. So we are multiplying 38 times 75. 28 of the letters out of the 75 I would expect to be C's. Let's try guided practice number 1. I can help you figure out what type of probability I'm using before you actually solve this by yourself. A bag holds 120 marbles. You randomly draw a marble from the bag 15 times. Okay, see right here when it's telling me that I'm actually doing something 15 times, this is going to be experimental. Experimental is favorable over the number of trials. Each time you record its color and replace the marble in the bag, you draw 6 blue marbles. What is the probability of drawing a blue marble? Now there are 2 questions to this, okay? Here's the first question, here's the second question. So the first question is to set up the probability. The second question is to predict out of the 120, okay, this is like find the probability of 120. So you're actually doing the multiplying by 120 for the second problem. Pause the video, try number 1, try number 2 of guided practice number 1. Favorable is the 6 blue marbles out of the 15 times, not the 120, the trials, how many times you actually drew the marble. 6/15 can be simplified to 2/5. So 2 out of 5 times I'm going to draw a blue marble. We're going to use that information to predict how many are in the bag. So if 2 out of the 5 times I draw it's a blue marble, that's 2/5 of the 120 marbles. Multiply 2/5 times 120, you should have an answer of 48. Oh, and I did forget to change it to a percentage. Remember, 2/5 is 40%, because 2/5, when you turn it into a decimal, is 0.4, and that gets you 40%. I don't care if you give me a fraction, a decimal, or a percentage. They are all the same. The last thing I want to leave you with is just remember that theoretical, you are actually saying the words what if, okay? What if this happened? What if I rolled the dice? What if I did? And it is favorable over the possible. Where experimental You are actually trying to do the experiment. You're actually doing it. So this is favorable over the number of trials. You will need to know these, how to set this up. And then just remember, if you're trying to predict, if you're predicting how many are in a bag or how many, then what you're doing is you're taking the probability and you're multiplying it by the number of objects in the bag, or the number of sides of a die.